Let's look at some other examples using Avogadro's number. How many atoms of hydrogen are in one molecule of CH4? Note that we're looking at atoms of hydrogen in a molecule. And here we're just talking about that single molecule. So if we have one molecule of CH4, I know that molecule needs to go in the denominator because it's in the numerator. And I'm going to specifically label that as molecules of CH4 because I'm switching between CH4 and hydrogen. Based on the formula, I know I can find the number of atoms of hydrogen, which would be 4 atoms of hydrogen per molecule of CH4. And we get 4 atoms of hydrogen. While this was a simple example where we were starting with one molecule, we often are starting with a different number of molecules. And so this ratio or relationship here in the middle is what's going to help us get between molecules and atoms. How many moles of hydrogen atoms are in 1 mole of CH4 molecules? Let's break this down a little bit. We're going to have a column of molecules of CH4 and atoms of hydrogen. For every 1 molecule of CH4, we have 4 atoms of hydrogen. If we have 2 molecules, we have 8 atoms of hydrogen. If I have 12 molecules, I have 48 atoms of hydrogen. And another way we could describe that 12 is by calling it a dozen. So we could say we have 1 dozen molecules of CH4, and therefore we'd have 4 dozen atoms of hydrogen. Those numbers, 12 and a dozen or 48 and 4 dozen, are equivalent to each other. However, it's just a different way of saying the same thing. If I go on and say, what happens when I have 6.022 times 10 to the 23rd molecules of CH4? I can say I have 4 times 6.022 times 10 to the 23rd atoms of hydrogen. Just like with 12 and a dozen, another way we can represent the 6.022 times 10 to the 23rd is by calling it 1 mole. Therefore, if we have 1 mole of molecules of CH4, we have 4 moles of atoms of hydrogen. So B is the correct answer. How many atoms of hydrogen are in 1.00 times 10 to the 23rd molecules of CH4? In this one, we're going to use that relationship that we just determined in the previous problems. We start with our known, the 1.00 times 10 to the 23rd molecules. We know we need molecules in the denominator. We know that 1 molecule of CH4 has 4 atoms of hydrogen. Molecules will cancel out, and we can do the calculation and find that we get 4.00 times 10 to the 23rd atoms of hydrogen. Given the numbers, you might have been able to do this in your head without setting it up. But learning how to set it up with a simpler problem will make it easier when we do more complicated ones. So C is the correct answer. How many moles of C4H10 contain 4.00 times 10 to the 15th atoms of carbon? In this case, we're not starting with the amount of the compound, we're starting with the number of atoms, but we still take the same approach. We have one number which has a simple unit. We're trying to find a simple unit for the answer. So we're going to start with the 4.00 times 10 to the 15th atoms of carbon. I know that atoms has to be on the bottom, specifically atoms of carbon, because that's what's in the numerator on the previous step. And I can relate that to molecules of C4H10. And I can get the relationship of 4 atoms of carbon to 1 molecule of C4H10, and that comes straight from the subscripts of the chemical formula. Now that I have molecules, I can get to moles. Now atoms cancel out. Now I want to go one more step. I want to get from molecules to moles. Therefore, molecules has to go on the bottom of the next step, and I know a relationship between molecules and moles, so I can plug in those values. 1 mole of C4H10 has 6.022 times 10 to the 23rd molecules. Molecules cancel out, and my units that I'm left with are moles of C4H10, so I can do the math. 4.00 times 10 to the 15th divided by 4 and divided by 6.022 times 10 to the 23rd. Just a reminder to use the correct notation on your calculator to make sure you're actually dividing by 6.022 times 10 to the 23rd. We do the math and we get 1.66 times 10 to the minus ninth moles of C4H10.